Hello, and welcome to your Dictionaries and Sets lecture. So the one thing that I want to cover about dictionaries that we didn't cover in the last lecture is the in operator. Now, we've used the in operator before to do things like check if a letter is in a string or if an item is in a list. And since a dictionary is a collection, just like a string or a list, we can also use an in operator here. However, when we use the in operator for a dictionary, it's checking whether an item is a key in the dictionary. So for instance, in line 6, we say print name in D. This would return true because name is a key in our dictionary D. However, print Chelsea in D would return false. Now, Chelsea is in our dictionary, however, it is in our dictionary as a value, and the in operator is checking if a value is in the keys of the dictionary. So if we did want to check if something was a value in our dictionary, we could say, for instance, on line 8, print Chelsea in D.values. However, we wouldn't use the in operator directly on the dictionary. We would have to use the class method values to grab the values and then check if our object is inside that. All right, so here we have a dictionary grades that has keys representing people's names and values representing their grade in a class. We're going to use this code to check for someone's grade and see if they're in our dictionary. So I'm going to ask the user for input, whose grade do you want? And then I'm going to print out name in grades. So this should print out true if I put the name John, Randall, Kim, Linda, or Sarah, and false if I put any other name. Let's go ahead and run this. All right, so we're going to say Python 3, dictionaries, blank. All right, so it said, whose grade do you want? Well, let's grab someone who's not there. We'll say Kendall. Okay, so you can see it printed out false because Kendall is not a key inside this dictionary. If we run this again and instead say John, then it'll return true because John is a key in this dictionary. So let's use this to basically grab the grade of someone if they are in our dictionary, and if they're not, we're going to go ahead and add them to our dictionary. So I'm going to go ahead and copy this, and then I'm going to add .capitalize because you never know when people are going to use weird cases. So capitalize, gorgeous. Okay, so I'm going to say if name in grades, then print grades square bracket name. So if we give it a name that's already in the dictionary, just tell us the grade. Else, so if name is not in grades, I'm going to say print this student does not have a grade. Oops, there we go, grade for this assignment. And I'm going to say G equals input. Please enter a grade now. Okay. So I'm going to ask the person for a grade if they don't already, if the person whose grade they asked for doesn't already exist. And then I'm going to use my trusty try and accept to make sure they gave me something that is actually a grade. So I'm going to say try G equals float G because they should give me a grade like this. And then if at any point we hit an issue, we're going to say accept print invalid grade, assigning grade of 0 for now. And then I'll say G equals 0. And then we're going to use our finally block. Remember, this runs if try or accept executes. And we're going to say grade square bracket name equals G. So if they gave us a valid grade, we'll put that in. Otherwise, we're going to say, hey, we're just going to put 0 for now. And finally, just so we can check our work, let's print grades. Now remember, like we talked about in a previous lecture, we can always throw an error if they give us an improper value. However, in this case, the desired behavior is just to give that person a 0 for now, and hopefully we can change their grade later. All right, let's go ahead and run this. So go ahead. So whose grade do I want? I want Kendall's grade again. Kendall. And it said that student does not have a grade for this assignment. Please enter their grade now. Okay, they got an 89.56. And so it says, okay, I'm going to add Kendall and I'm going to add their grade here. Let's try that one more time. This time I'm going to say I want Kendall's grade, and it's going to say, oh, that person doesn't exist. Okay, please enter a grade, and I'm going to enter 100%. I'm not even spelling that right, but that is okay. And so this is going to say, oh no, that's an invalid grade. I'm just going to give Kendall a 0 for now. All right, enough about dictionaries. Let's talk about sets. Sets are a new type of collection, just like strings, lists, and dictionaries that we've learned before. Sets are collections of unique elements. So for example, if we had the same object multiple times, a set will pare that down to just one. It just wants one example from every item in that possible set. Now, sets are mutable, meaning we can add things to them and we can remove things from them. The syntax of a set actually looks like some weird hybrid of a list, a tuple, and a dictionary. However, unlike dictionaries, we don't have key value pairs. Like lists and tuples, we just have individual objects separated by commas. Now, remember that I said that sets are collections of unique elements. So our set on line 1 is totally fine. It has 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's no repeats here, so this is totally valid as a set. However, if we try to create the set on line 3, where it says 1, 1, 1, 1, 1 over and over, 2, 3, 4, 5, 6, 7, 8, 9, when we go ahead and print out that set, it's going to get rid of all of the extra ones. Sets are only the collections of unique elements, so any repeated element is going to go away. Let's create a couple sets. So we're going to say my set equals, and then we're going to say empty curly brackets, remember, just like a dictionary, and then we're going to put the elements. So I'm going to say February, and then I'm going to say January, there we go, and then I'm going to say April. So this set is totally fine. There's no repeat, so it's just going to say February, January, April. In fact, I can test this out by printing out my set. And let's go ahead and comment out this code and run this. So when you run this, you can see we have a set with all of the unique elements that were in my set when we defined it. We can also, and maybe more commonly, we'll put numbers in sets. For instance, my set 2 equals 1, 3, 5, 9, 11. So this is a perfectly valid set. Let's print my set 2. And when we print it out, you can see again, we have a set with all of the unique elements. Now, what I was saying before is that if we have any repeats, it's going to get rid of them. So for instance, I am creating a set and I'm putting 1 in multiple times. But let's see what happens when I print that out. Okay. We'll run. Interesting. Our set is exactly the same as before. It got rid of all of the extra ones because remember, sets just want unique elements. And this can be useful to use as a way to see like what are the unique elements of another collection. For instance, I have my list equals and a bunch of numbers. I'm going to say my list to set equals set, and we're going to use a set constructor, my list. And when I go ahead and print out my list to set, you can see that it gave me all the unique elements that were originally in this list. So we can use sets to pull the unique elements from something. Now, one thing you can't do with a set is put a mutable object inside of it. So far, we've put strings and ints, which are all unmutable, same thing with floats and tuples. However, we can't put mutable objects like a list or a dictionary as an individual item in a set. For instance, let's try this. We'll say my mutables equals, create an empty set, put 1, 2, 3, 4, and then put 5, 6, 7, 8. So when we do this, let's go ahead and see what Python has to say about that. Okay, we got error, type error, unhashable type list. This is Python's way of telling us that you cannot put a mutable object in a set. You can, however, put any immutable object. So if we change those lists to tuples, let's see what Python does. Beautiful. So now we have a set with our tuples. We couldn't use a list because it's mutable, but since a tuple is immutable, it's totally fine to have in there. So while we can't put mutable objects, we can mix objects. So for instance, I'm going to say my mixed set equals, and I'm going to put 1, the string ant, the string blue, and the tuple 1, 2. Now when I do this, and let's just print it out for the fun of it, my mixed set, beautiful. When we run this, you can see that we totally can have a set with multiple types of immutable objects. So just like a list, not all of the objects in the collection have to be the same, but they cannot be mutable. All right, let's talk about set methods. We're going to talk about them in 2 groups. The first group includes the remove and the add method. As the names imply, and since sets are mutable and we can change them, we can add items to a set and remove items from a set. Remember, if we try and add an item that is already in the set is not going to add it because it already has an instance of that element, and we only want the unique elements in our set collections. Remove, if the item is in the set, will remove the item from that set. The next set of methods that we want to talk about is the specific to the set methods. If you have sets of unique objects, we can do things like look at the intersection, the union, and the difference of 2 different sets. And we can do that using set methods. So we made this set my set with February, January, and April. Let's go ahead and add June to that set. We can do that by saying my set.add June. And when you print out my set, we'll see that we now have an additional item. Beautiful. So you can see our set says January, February, April, and June. And this, we didn't have to say my set equals my set.add. We are just saying my set.add, and since the object is mutable, we're able to just add it in place. Similarly, let's try and add something that already exists. We'll say my set.add, and we already have this, but let's add February. And then we'll print my set just like before, and let's see what Python thinks about that. Okay, so you can see that when we added February to our set, Python said, okay, but it's already there. And so we didn't actually add anything to our set because February was already in our set, and we don't do duplicates with sets. All right, let's comment out some of these. Now we've talked about add, let's remove something. So currently our set would have February, January, April, and June. Let's say my set.remove January. And then print my set. All right, so let's go ahead and run this, and you can see that indeed it removed January from our set. All right, now let's get to the good stuff. Unions are the time when we take what's in one set and another set and combine them together. If we want to do this, there's actually 2 ways syntactically to do this. I'm going to show you the short way first and then the method way. All right, the first way to grab the union of 2 sets, and I'm just going to print these out so you can see them. You could also assign them to a variable. I'm going to say print odds pipe evens. And again, that pipe is kind of above your return or enter key on the right-hand side. And this is going to give us the union of the sets odds and evens, which you can see here are all the odd and even numbers between 1 and 10, respectively. The other way that we can do this is similar. We can say odds, so one of the sets, dot union evens. So you can say the name of a set, dot union, and then the other set that you want to put in union with it. So let's go ahead and run this, and we can see that they're exactly the same. Awesome. So you can see that both these things gave us the same exact answer. These are just 2 different ways to do the exact same operation. We can also look at the intersection of 2 sets. The intersection of 2 sets is the elements they have in common. So we can, for instance, say print odds ampersand pos ints. So this is going to tell us what is the intersection, what are the elements that are in common between odds and positive integers. And then another way to do this again would be to say odds.intersection pos ints. So these 2 things are equivalent, and when we print it out, you'll be able to see that that is exactly the case. So between odds and positive integers, the overlap is, well, all the odds, 1, 3, 5, 7, and 9. Next, we might want to know the difference between 2 sets. The difference between two sets are items that are only in one set and not in the other. For instance, if I say print odds minus primes, this should give us all the odd numbers that are not prime. So let's go ahead and do that. Another way to do this would be to say print odds dot difference primes. And let's go ahead and print that out. Helps if you spell it correctly. All right, let's go ahead and print that out. And you can see that both the subtraction way and the dot difference way gave us 1 and 9. So these are things that are odd numbers but are not prime numbers. Now, if you think about it, the difference between two sets is not symmetric. If we say odds minus primes or primes minus odds, you're going to get different things. Let's try it out now. We're going to say print primes minus odds, and again, equivalently, print primes dot difference odds. All right, let's print this out. And so you can see that the difference between primes and odds, basically numbers that are prime but are not odd, is 2. So you can see that difference isn't symmetric. It really matters which one you put first, which set you put first. So there is something called symmetric difference, and we can do that again 2 ways. We can say print odds caret primes, or print odds dot symmetric difference primes. All right, let's go ahead and run this. So you can see when you run symmetric difference, it's things that are in one set but not the other for both sets. So in our case, it would be 1 and 9, which are odd but not prime, and 2, which is prime but not odd. And this would also work if we did primes caret odds, because symmetric difference, as the name implies, is symmetric whether you put either set first. We can go ahead and test this out by saying primes caret odds, and actually let's just do 1 so we don't have to print it out a bunch of times, and let's run it, and you can see that still we get 1, 2, and 9 because again this is a symmetric difference. Okay, let's use what we learned to write some code to ask 2 friends to name a bunch of their favorite music artists and then print out a message telling them which artists they both like. Maybe you could use this, for instance, to decide what to listen to in a car ride, or like what concert you want to go to with your friend. So let's start off with songs. We're going to create a dictionary for this. So we're going to create an empty dictionary, and we're going to say for friend in range 0, 2. So I'm going to ask friend 0 and then friend 1. And I'm going to say f equals friend plus string friend. So this is basically going to give like a label to the current friend that we're on. And then I'm going to say print welcome plus f. So this is just going to print a welcome message, and then I'm going to say songs f. So from my dictionary songs, add the key for friend 0 or friend 1 depending on who we're there for, and I'm going to make it an empty set by using the set constructor. Then I would like to ask them what their favorite artist is. So I'm going to say name an artist you like, enter a blank to end. Then I'm going to say dot lower because of course you never know how weirdly people are going to capitalize things. And then I'm going to use a while loop to keep asking them for artists until they decide to stop. I'm going to say while artist is not equal to an empty string, songs f, so I'm grabbing the key for that friend from the songs dictionary, dot add, because remember, each of their dictionary entries will be a set. I'm going to add to that set their artist. And this takes care of the fact that maybe someone's going to accidentally put the same artist twice. Well, if they do, we'll just get rid of it because this is a set. And then, of course, I'm going to copy and paste this line and ask them for their next artist. And this while loop should continue until they've given us all the artists they want to and give us an empty line. All right, so I'm going to go ahead and print great job just to tell them they're done entering artists. And then I'm going to say print the artists, there we go, you have in common are. And what I'm going to do is I am going to create an intersection of the two sets, right? We should have one set for friend 0 and one set for friend 1 of the favorite artists that they listed. And I want to know which ones are in both sets. So for that, I'm going to use the intersection. So to do that, I can say songs friend 0 and songs friend 1. So these are going to be the two entries in our dictionary, and I am creating the intersection of these two sets. Now, to make it pretty, I'm going to go ahead and make this into a string. So what I'm going to do is I'm actually going to make this a list. So once I have the intersection of the two sets, I'm going to change it to be from a set to a list. And then I'm going to use the .join method, which is a string method that allows me to join elements in a set together. So the way we do that is we say what we want between the items. I'm going to say a comma, .join, and then the list of all of the songs that they have in common. So again, I am creating the intersection of two sets. I am turning it into a list, and then I'm using .join in order to join all of those so we can print it out beautifully for the friends to see. All right, let's go ahead and run this. And so first it's saying, welcome friend 0, name an artist you like. Okay, so I'm gonna say Beyonce because, of course. I'm gonna say Doja Cat. I'm gonna say Michael Bublé. It is almost the holidays. I'm gonna say Mariah Carey. I'm gonna say the Spice Girls, and then I'm done. So now it says, okay, we're done with you, friend 0. Friend 1, enter who you like. Okay, I like Megan Thee Stallion. I also like Beyonce. I like My Chemical Romance. I like Maroon 5. And I like Doja Cat, and I like Britney Spears. I have eclectic taste. All right, so I'm done. And now you can see, great job. Okay, so we finished. The artists you have in common are Doja Cat, Beyonce. So as you can see, we can use sets to both grab unique elements from things as well as compare different sets. Here we compared sets of artists that people liked, but you can use this in a lot of different contexts. All right, that is all I have for you. I will see you next time.